Very good morning and welcome back, guys. My name is Akriti, and in this lecture, we will be solving one question of linked list. From Leetcode, of course. This is our question. This is the question number 234, palindrome linked list. Okay. So, in this question, we are given a head of a singly linked list, and we have to return true if the linked list is palindrome, or we have to return false if it is not. Okay. What exactly palindrome is? Palindrome list is something which is same from starting and end. Like here in this example, you can say if we will start traversing from starting, we will find 1 2 2 1, and if we will start traversing from the end, then we will also find 1 2 2 1. You can see either if you are traversing from the starting or if you are traversing from the end, the linked list will be same. So such kind of linked lists are known as the palindrome linked list. In this question we have to check this only, that whether the linked list is palindrome or not. Okay. So the first thought which will came across your mind for solving this question will be the one that let us first reverse the linked list and then check and then compare each and every element of the reverse linked list with the original linked list. And if the element found to be same, then we will point our pointer to the next element, or you can say next node of the linked list. And if any element are not found same, then we will return false. Okay. So this is the procedure. In place of reversing the linked list, we are simply what we are going to do. We are going to store. We are first of all going to traverse our original linked list. Then while traversing only, we will be storing each and every node of our linked list in a stack, and after that we will compare our original linked list with the element which are pushed into our stack, because as you guys know, stack is based on the first in last out approach. The element which will be pushed into the stack first will came out of the stack lastly. We will find all the element in a reverse manner. This is what we are going to do. Sorry. Sorry. Let us consider this is our linked list. Okay. So firstly, what I'm going to do, I'm going to point my pointer here. This is my pointer. Let's call it temp pointer. Now what I will do, I will start traversing from the starting. Now as I will be traversing, I will be pushing the element of the linked list here one into my stack. So I'm pushing my one into my stack, and I will move my pointer to next element. Now I'm pushing my element 2 in a stack, and I will move my pointer to here. I will be pushing my element 3, and my pointer will be here, and I will be pushing my element 4, and now my pointer will be here, and we will keep doing this until sorry, it was 2, and we will keep doing this until our pointer reaches to null. Okay. So now as you can see, we have pushed all the elements of the linked list into the stack. Now what I'm going to do, again I'm going to traverse my linked list. Okay. Now I'm going to traverse my linked list again for the next time. My pointer will be pointing to the head. This is my temp pointer. Now I'll check if the value in this node is equal to the element which is at the top of our stack. We will be comparing, is 1 equal to 1? Yes, it is. Then what we are going to do, we are going to pop our element from the top. We will be popping our 1 from the stack, and we will move our pointer to the next element. Now again I'll check if 2 is equals to 2. So yes, then we will pop our 2 as well from our stack, and we will move our pointer by 1. So now pointer is pointing to 3. Now we will check if the value of the element which is inside a node is equal to the topmost element of our stack, then yes it is. So what I'm going to do, I am going to pop my element from my stack, and I'm going to move my pointer by one. So this is what I'm going to do. So now again I will see 2 is equals to 2. I will be popping this and my pointer will be here. Now again I'll see 1 is equals to 1. So if your temp pointer reaches to null and you don't find any element which is not equal to the top element of our stack, then it means that our linked list is palindrome. Or if you will find such condition where the topmost element of the stack is not equal to the value of your node, then we will be returning false. So this was the procedure what we are going to do in this question. So let's code it. First of all, what we have to do, we have to initialize a stack, empty stack you can say. We will be declaring an empty stack. So stack int, of course it is going to store integer, so data type will be string, sorry, integer. So we have declared a stack. Now I will be declaring so the first and the foremost condition which we should check is if our linked list is empty or it has only one node. Okay, so like if head is equals to null or head next is equal to null. Like in this case what is going to happen, if a linked list is empty or either it has only one node, then we know, then we need not to check if it is palindrome or not, because the linked list with the one node will all of course be palindrome, and the list which contain nothing will of course be palindrome. So in these two cases we will be returning zero without checking anything. So this will be our the cases which we need to check in the starting only. Now I will be declaring a temp pointer um, which is going to traverse my linked list, and I will be pointing it to the first node of our linked list. So while sorry okay, while temp is not equal to null, um, we will be traversing uh, until temp is equal to null. So what we have to do, firstly we have to store all the elements in our linked list into our stack. Okay, so we will be pushing each and every element in our stack. So s dot push temp value. Okay, so I have pushed it and I will be pointing my pointer to the next element. Okay, temp is equal to temp next. So this is what I had to do in the uh, first loop. Now when we will be out of this loop, then we have a stack with all the elements of the linked list inside it, where the topmost element is the last element of the linked list. Okay, so now I will start checking. So firstly I have to point my time again to the first element of the linked list. Now I'll check if the element if the topmost element of the stack is equal to the element which is there in a node. This is what we have to check. So I will be running my loop until temp is not equal to null. Okay, fuck yeah. Okay, so this is a loop while temp is not equals to null. So what I have to check? I have to check if the s dot top means the topmost element is equal to uh, the value which is present in a node. Okay, if it is, then we will simply pop our element, then as dot pop, and we will point temp to the next node. Okay, if it is not, then we are simply going to return false, because in this case our linked list is not palindrome, because even one element doesn't match then our linked list is not palindrome. And if we have completed this loop and now we are out of this loop, so it simply means that we have traversed all our entire we have traversed our entire linked list, and each element of the node which each element inside the node was equal to the topmost element of the stack. So it simply means that the apne linked list is palindrome, because it is equal to the reverse linked list which we have stored in our stack. So we are going to return true in this case. So this was the solution. Let me check it first. So our answer is accepted, and as soon as I'll submit it, you can see it's accepted. Okay. So this was the entire solution of our question, palindrome linked list. So let me explain you again the entire solution what we have done from the starting. So from the starting what we were doing, the very first line, the very first case which we are checking is if our linked list contain if our linked list is null, like it has no node or it has only single node. So in these two cases we don't have to check if the linked list is palindrome or not, because the list with the only element and the list with nothing will of course be palindrome, because either if you are traversing from the last or from the start, you have only one element, so of course you will find the same thing. Okay, so in this case our linked list is palindrome, so we need not to check anything. Now for the rest of the cases what we are doing, we are storing what we're doing, the main thing was we have to compare a original linked list with the reverse linked list. Okay, in order to check if it is palindrome or not. So for creating a reverse linked list, we are not actually reversing it. Instead, we are just storing each element in our stack, because the element which we found after, because the kind of list which we will found after storing all the element in a stack will be like the reverse linked list, because in a stack you can see the element which we will store first, we will access it last. Okay, so the last element will be the first element for a stack. That's why we are storing in a stack for considering it as a reverse linked list. So the list which we will be having in a stack will be the reverse linked list. This was the main thing what I was trying to explain you. Okay, so now we are having our reverse linked list in our stack, because we have stored all the element of the original linked list in the stack in this loop. Okay, so now what I'm going to do, again I'm going to start traversing from the very first node of our original linked list, and I will be checking if the value of the node is equal to the topmost element of the stack or not, because stack is a reverse linked list. So we simply just assume that stack is a reverse linked list. So we are checking if the element in the original node is equal to the element in the reverse node or not. Okay, in the reverse list or not. Okay, so if the element is equal, then what we are going to do, we are going to increase our pointer by 1. Similarly in stack we are going to pop that element so that we can access the next element. Okay, so now I have done this, and I will keep doing this until we are getting all the elements same. Okay, so if we don't find any of the elements same, like suppose I have this one, and this is the one. This is the first element of our original linked list, and this is the first element in the stack. So if we are comparing these two, then we don't find the one is equals to two, because these are not equal, of course. So then we are going to execute our else statement, and in this else statement we are simply going to return false, because even if one elements are not equal, then our linked list is not palindrome. So we are going to return false. And if we have completed our loop and we have reached to the last node of our linked list, or we have empty the entire stack, then simply we are going to return true, because our linked list is palindrome in this case. Okay, so I hope you have got the solution well. And if you have any query or questions regarding our solution, then you can ask in comment box. Thank you so much.